Hello viewers, I am Kausalya. Today we are going to discuss about state model of a linear system. So a state model of a linear system has two equations. One is known as state equation and another one is known as output equation. So what is meant by state? State is nothing but it refers a condition of a system at a particular time instant, right? So here, state equation is expressed as a function of state variables and inputs. So, for a linear time invariant system, the first derivative of the state variable. What do you mean by first derivative? That is, when you differentiate first time, that is known as first derivative, right? So, first derivative of the state variable can be expressed as a linear combination of state variables and inputs. Right, because state equation is expressed as a function of state variables and inputs. So for a linear time invariant system, the first derivative of state variable is again expressed as a combination of state variables and inputs. So here x1 dot, this is your first derivative. So this is expressed as a function of a11 x1 plus a12 x2 and it extends up to a1n xn plus b11 u1 b12 u2 and it extends up to b1m um, right? So this is for your x1 dot. Likewise, we are framing expressions for x2 dot and again we are framing finally xn dot, right? So here aij and bij are known as constants. That is, here we are writing, right, a11 a21 and similarly b11 b21. So they are constants, right? Again, now we are going to write the same expression in the form of matrices. So here when you express it in the form of matrix, you see on left hand side we are having x1 dot, x2 dot and extends up to xn dot. So here we are writing it in matrix form, right? This is a column matrix. And next thing, here we are having two terms, right? a11 and x1 and these two terms are in, they are get multiplied here. So here I am splitting this constant terms as one matrix and this x1 x2 terms as another matrix. You see here we are writing like this, right? a11 a12 up to a1n, again a21 a22 a2n and this a11, that is this matrix gets multiplied with this matrix. So here I had written x1 x2 x3 separately as another matrix, right? Likewise, here again you see we are having b11 b12 and it goes on and this b11 gets multiplied with u1. So I am framing a individual matrix for b term and another matrix for u term. So here when you observe, you see b11 b12 b1m and this gets multiplied with u1 u2 u3, right? So here the above matrix equation can be written as, we are again simplifying that matrix equation. So x dot of t is equal to a x of t plus b u of t, right? Here a11 a12, likewise the entire matrix is replaced by capital A and similarly b11 b12, the entire b matrix is replaced by capital B, right? So this is the state equation of linear time invariant system, right? You see here x of t is the state vector of order n cross 1, right? Because this is a column matrix, right, of row 1. So n cross 1 and u of t is nothing but input vector of order m cross 1. And A represents system matrix of order n cross n and B represents input matrix of order n cross m, right? So the output at any time are functions of state variables and inputs. So here the output vector is generally represented as y of t is equal to, it is a function of x of t and u of t, right? That is, they are the function of input and state variables. And next thing is output variables can be expressed as a function of linear combination of state variables and inputs. Okay, based upon the state variables and inputs, we will be getting the respective output variables. Again, we are framing expression for output. So here y1 is equal to c11x1, c12x2, and it goes on c1n(xn) plus d11u1, d12u2, and it extends up to d1m(um). Right. So likewise, again we are framing expressions for y2 and it extends up to yp. And again here this c11, c12, d11, d12 are constants. Right. So again we are representing the expression in matrix form. So this is y1, y2, y3 up to yp, and here we are having c11, c12, and this extends up to cpn, which gets multiplied with x1, x2, x3 up to xn, plus again d11, d12, d1m, and likewise it again gets extended up to dpm, which gets multiplied by this u matrix u1, u2, u3 up to um. Right. So again when you represent this matrix in a simple form, we are having y of t is equal to c into x of t plus d into u of t. That is, you see, this entire C matrix is represented by capital C, and this entire X matrix is represented by x of t. Right. So here it is c into x of t. Likewise, this entire D matrix is replaced by capital D multiplied by u of t. Right. So here again x of t is nothing but state vector of order n cross 1, right? Because x of t is a column matrix. You see here we are having column, right? So here it is represented as n cross 1. And the next one is in u of t is nothing but input vector of order m cross 1, because here the maximum value is m, so we are representing it as m cross 1. And y of t is nothing but output vector of order p cross 1, because the maximum output limit we are setting it to p, right? And c is nothing but output matrix of order p cross n, and d is nothing but transmission matrix of order p cross m, right? So again here this equation is known as output equation of a linear time invariant system, right? And finally, the state model of a linear time invariant system is expressed as, you see, x dot of t is a x of t plus b u of t, and this is known as state equation, right? And here the output y of t, that is output equation y of t, is represented as c x of t plus d u of t, right? While solving problems, we will be more frequently using these type of equations, right? In order to make you the concept clear, I had explained this derivation, right? Just if you want to know how we are framing this equation, you can go through this, or else it is more than enough to remember these two equations for solving problems, right? If you have any doubt, let me know in the comment section. Thank you.